Today I want to go over chapter 3 labs. Lab 3.2020, it says the smallest number. Write a program whose inputs are 3 integers and whose output is the smallest of 3 values. If the input is 7, 15, and 3, the output is 3. In this lab, we define 3 different integer variables, num1, num2, and num3. We get num1, num2, and num3 using the CNS statement. We compare num1 and num2. If num1 is less equal to num2 and num1 is less equal to num3, num1 is smaller than both num1 and num3, so it's the smallest. We display num1. Else, if num2 is less equal to num1 and num2 is less equal to num3, num2 is smaller than both num1 and num3, so it's the smallest. We display num2. Else, we display num3. It means neither num1 or num2 are smaller. So num3 must be the smallest one. Lat 3.22 is interstate highway. It says primary U.S. interstate highways are numbered 1 to 99. Odd numbers like 5 or 95 go north-south, and even like 10 or 90 go east-west. Auxiliary highways are numbered 100 to 999 and service the primary highway indicated by the rightmost 2 digits. Thus, I-405 services I-5 and I-290 services I-90. So in this lab, we need to write some if statements. We can start by defining the highway number and primary number. We get the highway number from the user. We say if the highway number is less than 1, or highway number is greater than 999, or if you divide highway number by 100, and the remainder is 0, which means it's even, we have invalid. We display the highway number, and we go to the new line. Else, if the highway number is greater than 99, we display the highway number as auxiliary. We find the remainder of dividing highway number by 100. We put it in primary number. We display the primary number. Else, we put the highway number in the primary number, and we display the primary number as primary. It's some combinations of if statements, which we check some conditions. If those conditions are true, then we can see if the highway number is a specific number. Then we want to check to see display the direction. We say if a primary number modulus 2 is equal to 0, it's even. We display going east-west. Else it's odd. We say going north-south. So in this example, you see how we can use if statements to check some conditions. Lat 3.24 is exact change. It says write a program with total change amount as integer input and output the change using fewest coins, 1 coin type per line. The coin types are dollars, quarters, dimes, nickels, and pennies. So in this example, we define some variables. We have input var, num dollars, num quarters, num dimes, num nickels, num pennies. We get the input val. If it's negative, we display no change. We find the result of dividing num val by 100, that is dollars. Num dollars times 100, if you say input val minus equal num dollars times 100, you can find the next one. If we say num quarters equal to input val divided by 25, we get the next variable. Input val minus equal num quarters times 25. If you divide input val by 10, we get the num dimes. Num dimes times 10, we get the input val. Input val minus equal num dimes times 10. So when you say minus equal, it means you're deducting input val and num dollars times 100. You're putting the result back to the input val. We say if num dollars is greater than 0, if num dollars is equal to 1, we have dollar. Else we have dollars. It means if this is 1, we have $1. Otherwise, we have more than $1. If num quarters is greater than 0, we display num quarters. If num quarters is 1, we display quarter, otherwise quarters. If num dimes is greater than 0, we display num dimes. If num dimes is equal to 1, we display dum, else we display dimes. If num nickels is greater than 0, we display num nickels. If the num nickels is equal to 1, we display nickel. Otherwise, we put S. Same logic applies to pennies. If num pennies is greater than 0, we display num pennies. If num pennies is 1, otherwise we put S. Lat 3.25, which is a leap year, it says a year in the modern Georgian calendar consists of 365 days. In reality, the Earth takes longer to rotate around the sun. So in this example, we want to use some if statement. We have the input here, we have bool is leap year. We assume this is false. We get the input here. We say if the input here, modulus 4, is equal to 0. If input here, modulus 100 is equal to 0. If the input here, modulus 400 is equal to 0, we make the is leap year true. Else is leap year becomes false. So if you look here, we have several statements inside each other. We divide input here by 4. We find the remainder. We divide the input here by 100. We find the remainder. So depending on which one of these conditions are true, this if is leap year becomes true. You can see that this closed brace is for that open brace. And this closing brace goes with this open brace. We check different conditions. We see if it's a leap year, display leap year. Else, display not a leap year. So Lab 3.26 is the name format. It says many documents use a specific format for person's name. Write a program whose input is first name, middle name, and last name, and whose output is last name, first initial, and middle initial. If the input is Pat, Silly, Doe, the output is Doe, PS. If the input has the form of first name, last name, the output is last name, comma, first initial. So this lab is kind of tricky. We define several string variables for user input, for first name, for first initial, for middle initial, for last name. We define the space index 1 and 2. We use the get line to get the user input. We find the space inside the input, that is the index 1. We find the next space, which is user input dot find space, space index plus 1. And then that is the second index. We use the substring function to go from 0 to space index, and we get the first. We use the substring function to go from 0 to 1. That is the first initial. We say if the user input dot find space index 1 plus 1 is not equal to string inputs, the middle initial will be user input substring of space index 1 plus 1 comma 1. So the last name will be the user input substring space index 2 plus 1 user input dot length minus a space index 2 plus 1. So in this example, we're parsing the input using the substring. We're finding where the space is. We use the substring to cut the string from space to the first, from 0 to the first space. We get the first character. We use the find function to find the space. And then we say, as long as we don't find it, we find the initial, middle initial. This substring will give you a part of string. And then we get the last name using the substring again. So it's parsing the string. It's breaking down the string to different parts and then processing it. Lab 3.27 is the login name. Write a program that creates a login name for a user. Given the user's first name, last name, and a 4-digit integer as input, output the login name, which is made of the first 6 letters of the first name, followed by the first letter of the last name and underscore. We define login first and last. We have an integer number. We say CN first, CN last, and CN number. If length of the first is less than 6, The login becomes first plus last dot add 0 plus underline plus toString of number modulus 10. Else login will be the first substring from 0 to 6 plus last at 0 plus dash plus toString of number modulus 10. We display the log. So you can see that we're using this length function to check the length of the string. If it's less than 6, then it will be the first plus. We use the add function to access a specific character in the last string, which is the index 0. We use the toString to convert number modulus 10 to a string, and then we put them together. This is how we can do the lab number 3.27.